This will be for the con exercise, limits of combined functions, sums, and differences. All right, so we have functions g and h on the graph, and they want us to know the limit as x approaches 0 of g of x minus h of x. So what we want to do here is very simple. This right here is going to equal the limit as x approaches 0 of g of x minus the limit as x approaches 0 of h of x. All right, so we're just going to find the limit of each graph individually and then subtract. All right, in both cases, we're doing x approaches 0. So on the x-axis, this is 0 right here. We're approaching this line right here. Okay? On this side, we trace the graph to x equals 0, and we land right here. This is 1, 0. This is actually y equals -1. And then from the other side, trace the graph to x equals 0. It lands on the same one. So on this one, it's going to be -1. And then on the other graph, here's the x-axis. X equals 0 is this line right here. All right, we're approaching x equals 0 from this side, and it lands at y equals 0. And from this side, it lands at y equals 0. All right, so for the g function, we got -1. For the h function, we got 0. So right here, this was -1, and this was 0. Okay, and -1 minus 0 is just -1. Answer A. So if you'll notice, they said the same thing I did. So this is what they asked us, and you can just separate g of x and h of x, the limit as x approaches 0 for each one, and just subtract them. So that's exactly what we did. All right, here's the functions, h and g. Once again, we're doing the limit of h of x minus g of x as x approaches 3. So we're going to do that on each graph. All right, x approaches 3. Here's x equals 3. So we're looking at this line right here. Now on this graph, we're coming from the negative side right here. X approaches 3, y equals 2. From this side here, going to x equals 3, we land here. That's going to be y equals 5. Okay, it's a mismatch. So what we have here is DNE does not exist. Limit doesn't exist. All right, I actually made a mistake. Even though I got this correct. If you end up with it does not exist, you can try another method. And what you can do here, you can say the limit as x approaches 3 from the negative side of h of x minus the limit of x approaching 3 from the negative side of g of x. And that must equal the limit as x approaches 3 from the positive side of h of x minus the limit as x approaches 3 from the positive side of g of x. So if you get it does not exist, we can do one-sided limits, okay? But you have to do both one-sided limits. You have to do the negative side, and you have to do the positive side and they have to equal each other. If they don't equal each other, then it does not exist. So let's try it. All right, we're going to x equals 3. So again, that's right here. So from the negative side, if I trace the graph, I land at 2. And then on this one, from the negative side, if I trace the graph, I land at 2. So that's going to be 2 minus 2, which is just 0. Now let's try it from the positive side, all right? We're going to x equals 3. From the positive side, I land right here. That's 5. From the positive side, going to x equals 3, I land right here. That's 2. 5 minus 2 equals 3. And we can see that we got 3 and 0. 3 does not equal 0. So now it is DNE, does not exist. So I got it correct, but I really didn't do it the proper way 100%. Okay, here we're approaching -1 f of x minus h of x. All right, x equals -1 on the x-axis. That's right here. And -1 right here. All right, so let's do it from the negative side first. We're coming from the negative side. We're approaching, and we're at y equals 2. And on this one here, from the negative side, we're approaching, we're at y equals 1. So 2 minus 1 is going to equal 1. All right. And now we'll do it from the positive side, approaching x equals -1. From the positive side, we land right there. That's y equals 1. From the positive side, going to x equals -1 right here, we land here. That is 0. So 1 minus 0 also equals 1. It checks out, 1 and 1. So even though this individual limit does not exist at x equals -1, we can do the one-sided limits for both graphs, and if it equals the same number, then that is the answer. Answer B. All right, here we have the limit of 0.5 h of x. So that's going to be the same as 0.5 times the limit as x approaches -3 of h of x. All right, so if we just find this right here, the limit of h of x as it approaches -3, multiply it by 1/2 or 0.5, and we're good. So let's do that. All right, let's go to x equals -3 on the x-axis right here, and we're looking at this line right here. All right, we got to approach that from both sides. So coming from the positive side, we land there. That's y equals 4. From the negative side, we land there. Y equals 4. All right. So the limit is 4, but they're asking us 0.5. So it's just going to be 0.5 times 4. And of course, that equals 2. So in their answer, they said the same thing. In order to find this, just take the 0.5 and move it outside. Find the limit as x approaches -3.